Alright people, it's time to climb up onto the land. Let's go to concept 34.5, tetrapods. Tetrapods are gnathostomes, which are creatures with a vertebrae and a jaw that have limbs. One of the most significant events in the vertebrate history was when the fins of some lobe fins evolved into the limbs and feet of what we now call the tetrapods. So there's a very funny cartoon from years ago called The Far Side by Gary Larson, and here's a famous one of his cartoons. It says, "Great moments in evolution." And so I like that one because it always kind of reminds me of kind of a humorous reason of why the tetrapods might have evolved. So let's talk about some of the derived characters of tetrapods. Tetrapods have some specific adaptations: 4 limbs and feet with digits. So think of like fingers and toes of some kind, basically. A neck, which is quite different. If you think about most fish and most other creatures like that, they don't have a neck. A neck which allows separate movement of the head, fusion of the pelvic girdle to the backbone, the absence of gills, except some aquatic species that we're going to talk about, and ears for detecting airborne sounds. So you have to think that the life on land was quite a bit different than the life in the water. There were some various adaptations that had to have occurred before these creatures would have been successful on land because the environment was so different. So a lot of the derived characters of tetrapods have to do with making the changes necessary to survive and thrive on land. The origin of the tetrapods makes for some pretty good reading. There is some information that has been found fairly recently, and there is a particular paleontologist named Neil Shubin who wrote a book for the search for a particular fossil, and the fossil that was found was called Tiktaalik. Tiktaalik is kind of well known. If you look up news sources or you just Google Tiktaalik, you can find some information. This fossil that they found, Tiktaalik, was hypothesized to be found in a certain time period. So they were looking for basically a link between the fish and the tetrapods. And so they were looking for a particular fossil in a particular time period. And this is kind of shows, it's a good story that shows the power of science, because science is very the purpose of science is to provide a hypothesis that can then predict something that can be tested. So they said, okay, if evolution is correct, we would expect to find this kind of this linkage, this creature midway between a fish and a tetrapod, and it should be somewhere in this time period, this specific time period. And so we want to look in this certain layers in this certain area of the planet to try to find this fossil. So that was a prediction. If we're going to find this fossil, it's probably going to be in a certain layer, a certain geologic layer corresponding to a certain time period within a certain part of the world. And sure enough, they made that prediction, and they went out to test that by searching for fossils, and they found the fossil that they were looking for, kind of this link between the two. So the fossil's name, or the species, is Tiktaalik, nicknamed a fishapod because it's sort of midway between a fish and a tetrapod. Shows both fish and tetrapod characteristics. It had fins and gills and lungs and scales. It had ribs to breathe air and support its body like a tetrapod. It had a neck like a tetrapod. It had fins with bone patterns of a tetrapod limb, but it still also had, like I said, fins and gills and sort of some fishy elements to it also. So your textbook for page 710, it talks a little bit more about Tiktaalik, and I'll show you a picture. And then you might also want to do a search if you're interested on the internet for Tiktaalik, or this author Neil Shubin. He wrote a book called Your Inner Fish that discusses Tiktaalik and evolution in greater detail. It's a pretty good read. So here's a picture of the fossil that was found that they named Tiktaalik. It has certain fish characteristics like scales. Man, I keep hitting the wrong button, sorry. It has certain fish characteristics like scales and fins and gills and lungs, a combination of two. But it also had some tetrapod characteristics such as the neck and ribs and what we call a fin skeleton, a flat skull, eyes on the top of the skull as opposed to, say, on the side. So there were certain characteristics that made it look very similar to a tetrapod, and other characteristics that made it similar to a fish. It was kind of midway between the two. And that's exactly what they were hoping to find, expecting to find, if the theories of evolution and the various hypotheses regarding some evolutionary facts turned out to be correct. Tiktaalik could most likely prop itself up on its fins, but it probably couldn't walk because the little arms were not as developed enough to get it up onto the land and walk around on the land. But it could probably come out of the water a little ways and kind of prop itself up and maybe splash around, walk around in the shallow areas, sort of. The first tetrapods that would be, say, Tiktaalik and the more advanced creatures appeared about 365 million years ago, and here is an artist's sort of reconstruction or conception of what Tiktaalik may have looked like in that time period. Your textbook shows a good illustration of the limbs and the development of limbs, and you can see that there are some homologous structures that were kind of passed down from very early creatures all the way up into more modern creatures like amphibians and the various amniotes such as the reptiles, birds, and mammals. So let's move on and talk about some of the tetrapods. First we'll start with our amphibian buddies, and there's a couple different varieties of these. I wouldn't ask you to remember all these orders, but they include salamanders, frogs, and caecilians, all different types of amphibians. Amphibians, class Amphibia, are represented by about 6,000, over 6,000 species, and they include a couple different orders. The order Urodela here, which includes salamanders, which have tails, as you can see here. They include a Neura, which would be all your frogs and toads, which as adults do not have tails. And they would include also Apoda, which includes caecilians, which are, they look more like earthworms or some type of worm, but they're actually an amphibian. They're a legless amphibian that resembles a worm. So those are the three types of amphibians. You have basically your salamanders and newts and the like. Then you have your toads and your frogs. Then you have these guys, which are a little bit odd, the caecilians. But these are all creatures that haven't quite made it completely out of the water. They are tetrapods, but part of their life cycle still is reliant upon liquid water. Even their very name kind of tells you that that's the case. Amphibian means both ways of life, so it refers to the fact that these creatures kind of go through a metamorphosis. When they're in their larval stage, they still live in the water, around the water, and then as adults they become more terrestrial. Some of them still remain a lot of times in and around the water, but they don't have to be in the water the entire time. Most amphibians have moist skin that helps them breathe. They actually breathe. They have lungs, but they also kind of do gas exchange through their skin, so it complements the lungs in various sorts of gas exchange. So early on in their development as an embryo, or not an embryo, but as a larval stage, you know, they are tadpoles. They have little tails. They swim around in the water. Over time, they start to go through a metamorphosis where they lose that tail and they become more terrestrial. And then here we have two mating adult frogs. So the whole process of mating and reproduction still needs the water. They don't have eggs that can survive on the land. They would dry out and they wouldn't create babies. So they still are tied to the water for reproduction and the early larval stages. In most species of amphibians, fertilization occurs outside of the body, so the eggs and sperm are simply spread in the water or in the area outside of the body, and the eggs require a moist environment, have to be at least in the damp soil or in the pond or the lake, or they would dry out, desiccate on the land. In some species, the males or females, can be either in some species, males or females, actually kind of care for the eggs by storing them in pouches on their body, in their back, or sometimes even in their mouth, or sometimes even in their stomach. There are some versions of amphibians that swallow the eggs and hold them in their stomach until the eggs begin to hatch into tadpoles, and then they go and throw them up into the pond or the lake, or when they start bursting out of their back, they release the little tadpoles into the lake or the pond or the stream. Here's an example of a frog that has sort of these sort of pouches on its back, and inside those lumps are actually developing eggs that will become tadpoles and then kind of break out of the skin, and then she or he, in this case I'm not sure, will release those tadpoles into the water. One thing to note about amphibians is the population. The different varieties of amphibians have kind of been dropping lately. Amphibians are what we tend to call an indicator species. They are some of the first creatures that become most hardest hit when the environment starts to degrade. So their decline is oftentimes sort of a warning sign of environmental change or some sort of environmental problem. Lately, in the last 20 or 30 years, the amphibian population has dropped quite a bit due to a disease causing chytrid. Chytrid is a little microorganism, fungus. So a fungus that invades the frogs and causes an illness that has wiped out a number of species. So you put that on top of habitat loss and climate change and pollution, and a lot of our little amphibians, our frogs and our toads and those little creatures haven't been doing that well lately. There have been a lot of species that have started to die out. So amphibians are still tied to the water. They are tetrapods, but for reproductive purposes and for their larval stage, they tend to still need to be in the water. Next, we're going to move on to creatures that are not as tied to the water, and that is partially because of the fact that they can lay eggs that allow the baby to develop in its own little private pond within the egg. So we'll talk about amniotes coming up. Let's take a break, and we'll come right back.